So I'll just talk rubbish for about 15 seconds or so whilst it all gets warmed up and started. There's nothing really to do because nobody can hear me speak. And there's an advert playing, I imagine. Anyway, hello to all of those that are joining in. I know there's a few of you waiting around in the chat room to begin with. So today we're going to carry on with the code zone. And I've still got this horrible cough. So periodically I'm going to sort of interrupt and start coughing all over the place. So who have we got here? We've got, Magetsu's here, Apostolisk. I've got to be careful pronouncing some of these names. Standard Ints here again. Danicron, you weren't first, unfortunately. And Jacob's here. Good. You see, I've still got this little cough. It's not actually a problem with my throat or my lungs. It's a problem with the bottom of my esophagus that makes me cough. So I'm getting that looked at. Don't worry about it. I'll be fine. So we can see here we've got a planet. It resembles the Earth, and it's got shadow casting, and this is exactly where we left off last time. I've done no additional code, as I promised I wouldn't do. I did make a video. Hopefully the microphone's good, everybody. Thumbs up if the microphone's good. Morris, yep, excellent, is here. Saladin is here. Cool. Well, I've got most of the moderation team here. Hopefully some people will turn up to be moderated. And we put in some rudimentary camera following, and I think I'm going to expand on that a little bit today. I think we're getting to that point where it's time to turn this into a solar system. Alex, hello. Sorry, I know you were streaming, Alex. Sorry to interrupt. I hope it was a good stream. Now, somebody raised the question that, oh, hang on, it doesn't look like anything orbits anything other than the centre of the universe. Well, there's some proof here that that's not the case, because recall that this purple circle is in fact the centre of our universe. It's our sun. We've got the camera locked on to the planet rather confusingly, and we can see definitely that things are orbiting the planet. So I just wanted to bring that up in case you thought, well, actually it doesn't work at all. No, it's working just fine. The light source is, well, you can see it is the sun, and that's because we took the inverse tangent of our position in Cartesian space in the plane of our solar system to work out where we are relative to that center point. And because I carefully coordinated the orientation of the texture beforehand, it's a very cheap and easy way of doing illumination. That was a mouthful, wasn't it? Why can I never be like that when I'm making a video? When I'm making a video, it's far more stop-start and have to edit all these bits out. I apologise again for the cough. Hidden asbestos. Thank you for the follow. I've got a suspicion that's somebody that might know me. Right, who have we got here? So we've got Channel Mouse. Hello. Where's the planet's ice cap? Well, we don't have any, right? This is a forward-thinking code zone. If you keep burning tires in your living rooms and eating polar bears, eventually we're not going to have any of these ice caps. What do we got here? Vitoral. Yes. Oh, hi. Yes. Good. Is it? I've got to ask this. Is it Vitora or Vitor and split into Almeida? I think it's Vitor, isn't it? I always say Vitoral. I think it's just Vitor. The Joker. Thank you for the follow and hello. Slice. Hello. And Moscow-ish. Hello. Right, so I think it's time to time to cough everywhere. Sorry about that. It's going to keep happening. And we'll have a look at structuring our solar system a bit better, because right now we're creating everything as a standalone planet, and we're giving it variable names, and it's just not very convenient to have a mass of things to look at. Slater US, hello, and Trolled Woods, hello. Quite a few people. Good. I like to see. And the code is exactly in the same horrible state that we left it last time. So what I wanted to look at first was in our main game, you can see here I am creating sort of everything individually. And we're going to have to do that to actually populate the solar system, because I don't intend on doing any procedural generation as such. But I don't want to have to do this, which is where in our main loop, our on-user update, that I sit and have to call this on every single variable. Obviously, it's not very professional, is it? But it was good enough whilst we were getting set up and debugging. The other problem is it makes it difficult to sort of specify what it is that we want the camera to tack onto. So I'm going to start by looking at how we can store all of this better. And I'm going to do nothing fancy here. It's not going to be a complex data structure. It is just simply going to be to put all of these things into a vector. But then I think what we'll do is a suggestion that Ericsson made last week, which is you could use a couple of the keys to sort of tab between the planets that you're following. And I might put in a slightly more adaptive camera to make that. And we'll have to play with that because I think at different zoom levels we want the camera to behave in different ways. We may also do some background rendering as well, because we'll see eventually, because space is so empty, most of the time the camera's not looking at anything. A vector of non-owning pointers. Well, at the moment we're unsure what we're going to be doing with these pointers. I'm just making them pointers for the time being. They probably don't need to actually be smart pointers at all, but we are going to be, as we did at the end of the last episode, we did start to exploit some polymorphism, so being a pointer kind of makes that a bit convenient for us. Hey Nanoic, Zent, first time I catch up on a live stream. Well, it's probably going to be nothing but disappointment. I think that's what a lot of people, they come from the YouTube channel and go, hey, there's that slick YouTuber on the One Lone Coder channel, what amazing stuff he does, and then they look at the Twitch stream and see, actually it's a fairly messy looking, messy coding guy that coughs a lot and makes all sorts of mistakes in real time, and it's humiliating and embarrassing for me and not that exciting for the audience, but people keep turning up. So, no, you've only got yourselves to blame. Everyone joining Shouty Coders to watch your stream. Yes, and looks at my keyboard whilst I'm typing. Thank you very much. Right. James Dean, thank you for the follow. And we'll get another follow. See, they all pop up here. So we've had a Quiet Riot and Cute Inty. Cutinty, why not? Cutinty. So I'm going to replace these with a vector. And it's a very simple modification. But my vector is going to be of this shared pointer. Now, I'm getting to the point where we're thinking, we chose originally unique pointer in the very first episode, and then somebody said, oh, well, what if we made it shared? And then, well, I'm going to stick with shared for the time being. Eventually, I might actually just completely refactor pointers out of this entirely, but we shall see. So I've got my standard of shared pointers, my standard vector of shared pointers, and I'm going to call that MV Solar System. So that's everything. Very simple. And now I'm just going to add these things to the solar system. So whereas we've got here MP Sun, I'm just going to push this into my vector. So MV Solar System, I'm going to use the emplace back. Like that. There we go. And I'll do that for all of these planets. So if you have come over from the YouTube channel, or missing a bracket there, one of the things, firstly, other than this being a lot less professional, it's also completely unplanned. I've no idea what we will be doing during this stream. So I will be making mistakes, and we'll be making a lot of this up as we go along. I need some more brackets, don't I? There we are. Are you eventually going to have polymorphism with these planets? I've already got polymorphism with these planets. You'll see here that one of them is called Planet. And it's not complaining. The compiler is quite happy with that. Oh, let me zoom in a little bit. I forgot about that. Sorry, guys. Make sure you can actually see what's going on. Of course, Earth doesn't exist anymore now. And I'm going to change the selected to be just an integer index in our vector. So we can get rid of this now. Can I do it? Yes, okay, that's what we'll do. So we'll just have this as an index into our vector. MN selected planet. Now, as the game matures a little bit in the future, I think what we'll end up with is lots of things that float around in space, and we might want to select and target different things to look at. But for now, all we've got is planets. We may have ships and space stations and all sorts of things later on. I also can take a bit of a punt and get rid of these. So, well, you know, risky stuff like this, I just commented out to begin with. Now, this is where it gets a little bit fun, isn't it? Because now we need to put in these relationships. So we have to remember what these relationships actually are. So now we're getting rid of the variable names. I do need to have some way of identifying what's going on. I'll have you as sun, and you as earth, and you as moon, and you as you were sort of a secondary moon, weren't you? Yes. We had moon 1 and moon 2, and then one of the moons had a satellite. That was it. We don't need you anymore. So I do need to actually say mv solar system 0.get. Oh no, I don't want the .get, do I? Because I'm actually just passing in the smart pointer, so that should be like that. Yeah, there we go. So what was Earth is now index 1. So you're going to become an index 1, and you're going to become an index 1. And what was Moon 2 is going to become an index 3. Right. We could create some sort of tree structure to make this a little simpler, or read it from a file along with all of the statistics of our solar system. Just having a quick catch up with the chats and frequent slurps of water tonight because I really have got a fairly messy throat. My keyboard doesn't have a TV built in with Sherlock. I'd make some witty comments about Uma Thurman here, but I can't think of anything witty to say. Ha ha ha. Hi, Javid. Really enjoy your videos. Oh, thank you very much, Smash Highlights. Now you've got a problem with child-parent relationships since the elements of the vectors... Oh, well, we've just addressed that. Looks faffy. Yeah, it probably does look a bit faffy. I think you're right. Why am I skipping index 2? Because that particular moon doesn't have nothing orbits that particular moon. So the constructor of the celestial body class takes in the parent object, which we've called the principal. And we've been debating about this again this week. Should we be calling these actually the barycentric object? I don't know. Yeah, there we go. There's the parents. Oh, good. The chat's kind of looking after itself. Good. Yes. If you've got some questions and the chat doesn't answer, I'll probably not answer either. So we'll see. Right. Now we can get rid of all this because now we can just auto through our planets. So we'll call it, well, it's our bodies, isn't it? So we'll call this a body, MV solar system. Right now they're all planets though. That might not always be the case. Body, update self. There we go. And we'll take the same and we'll have the draw self property as well. Down here. Now the only thing that changed was this selected where we were setting the world offset. I'm just going to comment that out for the time being and just make sure that things haven't broken too much. But this means we can't lock onto a planet, so we'll have mouse control again. It'll allow us to pan and zoom around the universe. Here's something else that we should look at in fixing as well. It takes a while to load. There we go. So that's the center of our universe, the sun, and here we can see our planet very quickly whizzing around it. And that's why we had this ability to sort of lock onto the planets, because it became very tricky to follow. There's our 2 moons. And if we go on to this moon, I'm not going to be able to do this. I'm not going to be able to pan it quickly enough. There is actually something orbiting that one, a small satellite. Yes, I was going to... Sorry, completely distracted there. I want to make the images load a bit quicker. So the standard on Windows, the Pixel Game Engine, the standard image loader on Windows uses something called GDI, which is guaranteed to be there as part of Windows. It's what Windows uses to draw itself, or at least what it used to use. So it's kind of the... without needing to install any additional libraries, which of course is part of the mission of the Pixel Game Engine project. Image loaders, however, on Linux can't have access to things like the GDI. So instead on Linux we use libpng, and that's why the Linux programs out there, you link against libpng when you're building a Pixel Game Engine application. There is a third one called STB image. I've forgotten the name of it. There we are. OLC image STB. So if I define OLC image STB before I include it here, and in my project folder, space thing, there we go, I actually have the image, STB image header file. Now this is an image file provided by, I've forgotten his name, we'll have a look at the header file, because it's the STB are his initials, but it's a very popular header file, because one, it's enormous, but two, it allows you to open pretty much all image types, with nothing other than the inclusion of this header file. Yeah, it's quite a long one. Excuse me. But it's also very fast as well, so it's quite a useful thing for us game developers. It does allow you to do image saving too, so it's lots of things in there. It'll even open up things like a Photoshop document and allow you to navigate those. But by changing it to image STB from the default loader, we actually do get quite an increase in performance. Hopefully this will work, because I've been rebuilding the Pixel Game Engine recently and not tested this, so we'll see. So if I click run now, okay, it still has a white screen whilst it's loading the image. The images are very large, so it's got to create quite a large texture. But what I'll draw your attention to is when I click run, look at the little graph on the right hand side of the screen. Does it appear under my video camera? Oh, that's frustrating, it does. Just a second. If I just click on those, just disable those for a second. If I run that again, watch this little graph that appears and watch how quickly it climbs up. So that's as it's allocating memory and loading the texture. And we saw it did and loaded the images and out we starts the application. If I take out the image STB, so now we're going back to the GDI plus. And we wait, and we wait, and we can see it doing big chunks before it loads. So it's a faster library. Now we may even get some more speed, because right now we're compiling in debug, but if we compile in release with STB, almost instant. In fact, it's up and running before we can even start to see the graph. So if you're conscious about load times, and this is a particularly large image. This is a 2000 by 2000 pixel image, which is big for a game, particularly like a 2D game. Right, let me bring back most of my imagery. There we go. So we need you and we need you. Perfect. Let me catch up with the chats after that. So what have we got? Thank you, Alex. Where does PGE define the implementation of standard B image? Well, as you've just seen, you can actually modify how the Pixel Game Engine does various things with all of these hidden little code words, and they're not documented, and that's purely out of laziness more than anything else. But there's something called an image loader. Yeah, I know it's only 1200 frames per second. Oh dear. Holy Seraphimon, since you're not sure exactly what direction you want to take the program, what do you think of the idea of space economy? Well, yeah, I'm all up for sort of an elite style game. I think that's ultimately where this is going to go. But we just need to get these sort of very foundations put in before we can start getting stuck into some of the more interesting things. But what I've noticed is a lot of people are taking from this series is actually how do they do some of the very basic stuff. I know I like to think that, oh well, people obviously know how to do that, but it's easy for me to say it when actually there's quite a lot of people that don't know how to do all of these very basic things. So yes, it's a slow burning series, and it seems like we'll be here for thousands of episodes before we get to full on gameplay. But you'll be surprised once we've got these basics out the way, just how quickly things will start moving. Right, back to the main game. So, okay, we're kind of happy that's all up and running. We now need to fix our selected planet tool again, because right now it doesn't work. That's what we say up north. So, yes, do I actually maybe need to think this through a little bit? I think I'm going to change that to an integer. Because I'm going to save negative numbers to say that no planet is selected. And that way it's convenient, because if we're selecting planet 0, then it's valid. So if mn selected is greater than 0, then we need to find our planet, which will be in our vector mv solar system, mn. What did I call it? Obviously not. MN selected planet. I'm being too verbose with my variable names. Just zoom in a tad there. MN selected planet. We close U, get the Cartesian. There we go. The red wigglies have disappeared. All is well. Obviously that means it's perfect. It's fine to ship it now, right? It's done. Once all those red wigglies have disappeared, we're good. Golden. Let's go. But I think before we click run, I'm going to add some... Yeah, I'll add some keys that we can actually navigate the planet as Ericsson wanted us to do. So we'll just check for if... we'll use Q and W to iterate backwards and forwards between planets. Yeah, okay. Okay, Q... dot be released. Oh no, we'll do be pressed, so it feels a little bit more responsive. If we press the Q key, then we're going to go backwards. We'll worry about that one in a minute. Let's do the easy one first. If we press the W key, or maybe we want W and things for flying ships later on. Decisions. Well, we can always change the key later on. Key W dot be pressed. Well, this is simply a case of increasing our index now. Much easier. So I can just plus plus. But I probably want to make sure that it doesn't go beyond the size of the vector that's containing all of our planets. So let's just double check for that as well. Plus 1, and we'll just mod by mv solar system dot size. Right, so hopefully that should allow us to iterate forward through all of the planets. Iterating backwards is a little bit trickier. There's a trick here, isn't there, where you add on the size of the... Yeah, basically we do sort of 2's complement almost, in a way. Something like that. I think it's something like that. Let's try that anyway, we'll see what happens. Okay, right, so we're not following anything because we're at -1, so if I W, now we're following Earth, now we're following the Moon, now we're following the little thing, now we're following the little thing that's following the little thing. If I press W again, where are we? Interesting, I've got a -1 in there anyway. I mean, that's kind of good. But I can't select the sun, so I'm never going back to 0. We go backwards. Our 0th element is never appearing. The mod approach is neat, but nothing beats the readability. Oh, did I check for... oh, yes, I did. Nah, well done, Standard Int. See, somebody's paying attention. Yes, I was wondering, why wasn't I getting 0 there? Okay. Right, so... I've got my planet selected. So I do need to be able to go into sort of free camera mode as well. And I'm going to do that with the tab key. So if get key OLC key tab dot be pressed, all I'm going to do is set my selected planet to -1. It's basically to get... I was thinking, should I do it more sophisticated? Right now, that'll be enough. So I can always sort of dip out into panning and zooming with the mouse. So there's our sun. Yeah. So now we're iterating through all of the things in our system. I can't pan and zoom with the mouse, but if I press tab, yes, it became sort of free flowing. And I can press Q and W again to go back to sort of iterating between the planets. Excellent, good. We have a way of navigating our very simple solar system. Soon we'll be flexing our C++ debugging skills. I like that. Well, we fixed the not selecting anything option now with the tab key. But I'm thinking I don't want it to sort of immediately snap between sort of one planet and the next. So I think what I'm going to do is add a camera with some sort of lazy interpolation that should try and sort of quickly pan to the right place. Now, what I don't know is how well that's going to work at the different zoom levels, because if we're really zoomed out, in theory, our planets are thousands and thousands and thousands of units apart from each other. So how fast is the camera going to move? And I think maybe we want to tune that based on zoom level. Don't know, all very experimental. But it is telling me it is time to bring in a camera variable of some description. Now, by default, that will be looking at the center of our universe. Hang on, something went ping. Some follows. Oh, quite a few follows. Thank you all for following. I'm not going to be reading them all out individually, but thank you very much. It is appreciated. Let's have a look. So we've got our camera, and we're going to... See, when I pan... see, maybe I do need to think about the different camera modes, because when I'm panning, I don't want the camera to sort of be slightly lazy, just the selection ones. Right, so let's try this anyway. Let's see what happens. This is where we're setting where our current camera is looking. So I'm tempted... excuse me. Tempted to add our code here. So, if we have our MV camera, I will make the thing, by the way, where you can type something in the chat and it will make stuff fly all over the screen when I make mistakes. I know that seems to be a popular thing. I don't know why, but it is. So, MV camera equals, and what I'm going to do is take the target coordinate. Oh! Darkstorm, thank you very much for the subscription there. Don't know if you can hear these notifications, but I certainly heard that one. Oh. Captain Hive, thank you very much again for your subscription. Much appreciated. It's little things like that keep me going, particularly at the moment. Oh. Light Smasher, oh dear, 3 people. Oh, there's all sorts going on in the chat. Hang on. Oh, thank you very much, Nanoic. Nanoic's gifting subs. So all of these people here, thank you very much. Gobfather and Agent Blackout 5. I don't understand Twitch at all. No idea what's going on. Javid will be forced to use doubles because of precision. Actually, Jacob, you're right, and we will need to address that at some point. I've been watching your NES emulator videos. Thank you very much. The NES emulator series was for me, it was a very important part of my life. I enjoyed doing that tremendously. Well, a whole bunch of subscriptions there. That was interesting. Thank you very much, Nanoek. Hidden asbestos. No, I don't know. You somebody I know, because if anybody knows me, they'll know I've had an asbestos problem recently. I do apologise for the coughs. I can't do much about it today. Right, what we were doing. I'm going to use what I know is called a Leaky integrator following system, which is I'm going to take the target coordinate, which is going to be where our planet is in space. Very simple list. And from that, I'm going to subtract our current camera location. Now, what I do next is take a very small proportion of that. And this is where we can make this tunable. Yes, hang on. Take a very small proportion of that. Let's say it's, for now, let's say it's 0.5. So half of that distance. And I'm also going to throw in our elapsed time here as well, just so things don't change too rapidly as the scene is panning around. And what I do then is I accumulate this small difference into the original camera vector. Now, I learnt this technique when I was studying, machine learning back in university, and we used to use a neuron type called a Leaky integrator neuron. There's lots of different neuron types, but it turns out most of them are rubbish, and most of them are so over-spec'd, and they're fantastically good at replicating biology, but totally useless when it comes to machine learning. And it turns out you can actually approximate a neuron to a very useful degree with this very simple equation. It's called a Leaky integrator neuron. And this is what you would use to accumulate all of the input and work out whether the neuron's about to fire or not. And you would simply threshold it, and if it fires, you could shove it into some refractory period, or you could reset it back to 0, whatever you want. All sorts of different things. But that's where I first discovered sort of this Leaky technique. Effectively, for the electronics guys out there, it's akin to an RC filtering circuit, so a resistor and capacitor in parallel, I want to say. I'm probably going to regret that. There's a big discussion about floating point numbers going on. We'll stay away from that. So once I've got my camera location and I've kind of leaked towards it like this, one of the benefits of this leak as well is because it's proportional to the distance away. If you're far away, you make a very large initial step. As opposed to it sort of being a slow scroll all the time. So the distance between the planets is kind of built into how this function is going to respond to them. But we will see, because now what I'm going to specify is our camera as the target for where we were putting our camera in the world space. Now, the one thing that's going to make this a little bit tricky is if I do pan and zoom, that no longer works. So for the time being, we will just go straight to selected planets. So let's actually, we've got a selected planet 0. It's going to be our sun, and we'll see what this works. Now, it might need some tuning. It might need a little bit of playing about with some of the numbers. We will see. So there's our sun, and if I go to the next planet, there we go. We get a nice sort of smooth transition, and we follow. Very nice. But this is what I was a bit worried about. I think the zooming isn't quite going to work in our favour. But let's go to the next thing, which was this one. Now, I'm not doing anything with the mouse. Yeah, we can see that one's a bit slow. Yeah, zooming it doesn't like. Zooming is what's going to cause us problems here. So that's one. It's got that one right because it's gone back to 0. So tell you what, I'm going to restart the application and just not do any zooming for the time being to understand what's going on. So go to the next one, and it does kind of move the planet. It's never going to move it directly to the middle anymore because it's always going to be following slightly. So we'll just adjust our tuning curve. Let's make it quite robust, so we can just check to see if things are working. Now, if we make this number too high, we run the risk of overshooting and running into oscillations, which is not going to be good for the user. That's a bit better. Go to the next one. So now we're looking at this. So in theory, that should stay somewhere. It kind of is and kind of isn't. Go to this one. But if I zoom in, yeah, zooming in is not good. Go back to our sun. Go to our planet. Go to the moon. Go to moon 2. It's kind of there. Yeah, I'm moving my can to a moving object, but the idea with the camera code is it kind of follows the object all the time, because it's not just happening once, it's happening every single frame. It will never catch up to the object, that is true. It can't do that unless we start specifying DAF numbers. So if we set this to 1.5, this now should make a too large a step as it's moving. Now we probably won't notice it very much at these scales. But as we zoom in, which at the moment we can't do either, you'll start to notice we actually overshoot the planet and it'll start to oscillate back and forth. It could be oscillating slightly now. But it's nice that we're sort of smoothly panning around the universe. We've just got no control over what we're smoothly panning around. And it does always look like we're sort of offset by the same amount. That's interesting. Yeah, should it snap to the planet once it's close enough? Well, I think there's a secondary problem there as well. Later on, if we're controlling a ship or something, the actual scale I want to play the game at is not with the planets really zoomed out. It's actually with the planets very much zoomed in. So if I just comment that out for a second and just go back to the normal panning, so the level of sort of depth that I want to play the game at, yes, I want to be able to see the system at these, I'll tell you what, I'm going to have to slow down time here a little bit. These are getting a bit too fast. So I kind of want to play at sort of that sort of level of zoom. So it actually takes you time to travel across the surface of a planet. I want things to feel big relative to your spaceship. So we will have to do some sort of different camera management when we start controlling craft in this solar system. So I think that'll look quite nice when you're sort of flying across the surface there. And the clouds will be moving. We've not actually put planet rotation and things in yet. Nor have we put in a gigantic sun right in the middle. Lerp's a straight line. Yes, lerp is kind of a straight line, but it's always lerping to a moving target, which is part of the problem. As Danderson said, it is a bit overdamped, right? So we never really get there. Now, we could fake it, right? We could put in sort of a really big number here. So if we change this from 1.5 to 150. Not entirely sure what's going to happen here. We'll have a look. Go to Earth. See, very, very quick and snappy. Go to the next one. But we're overshooting there. Oh, maybe I did. Ah, do you know what it is? Oh, dear me, I've been such a fool. I know what it is. It's because we're thrown in elapsed time here, which is bringing this number down to a very small number, and that's why now it's large. It's working better. Oh, dear me. Oh well. At least we've gained an understanding of what's going on here. So actually, we do want large numbers because that's kind of the behaviour we want to see. So if I just get my system up and running again, let's actually leave that running at that kind of speed. Right, so zoom to our planet. There we go. I think we're in the middle of the sun there. Yeah, that's why that one just goes blank. So let's just make that number now something a bit more manageable. So instead of 150, let's change that to 50. I'll leave the elapsed time in. Since we've found a scale that's working, we'll have to come up with a new constant. We'll call it the Ericsson. There we go. Nice. You can see on this one, it can't keep up. This object is too fast moving. That's why it's not in the center of the screen. But the slower moving objects, I'll zoom out a bit, well, at least they give you the impression that they're at the center of the screen. But anyway, we've got this nice sort of tweening going on between the objects. Should the rate be related to the speed of the object? Well, I kind of want, if you're really far away, maybe it should take a bit longer. Yeah, maybe not the speed of the object, but perhaps the distance it's got to travel. But right now, it makes a nice sort of... It's good enough, because if you're navigating between the planets, you can sort of see where they are relative to each other. Now, all of this is going to change when we actually start turning this into a solar system, because there's going to be so much empty space. And I think we're getting to the point where maybe we do need to draw the sun. Because one of the things that we did point out last week is as you zoom in, the circles become so large your frame rate basically disappears. Excuse me, as it's drawing billions and billions of pixels. So now we're in free cam mode. That's why my things just suddenly started wandering off the screen there. I think it looks really nice. And we can see slowly that the shadow is changing on the planet. A little bit of oscillation there. That's because we're drawing at a scale of 2 pixels. We can adjust that later on. Oh no, we're drawing at 1 to 1 on this, I think. There we go. We can fix little glitches like that later on. Happy with that so far. I'm not happy with this sort of line of noisy pixels along the edge here. Right, let's draw in our sun. Now, our sun's going to behave a little bit differently to the planet, so we created a planet class. Which just had some very basic things in it to get it drawn. A planet will effectively look after itself, will draw itself. Will the sun rotate? Yes, I think it will, but our reliable oracle of space formulae, Ericsson, has let us down in this regard. He's not provided us with a formula that determines how fast a planet rotates. Basically, he said it's entirely random and arbitrary and that there is no science behind it, which makes you think. So I'm going to create another class called star, excuse me, which is going to be, well, it's going to be our sun, right? Because the sun is a star. Add class. C star. Add that in. Base class. Do you know what? I'm not going to bother because I'm going to do some cutting and pasting. I'm going to grab all of you and stick you in here because it's pretty much the same stuff. Rename you C star, and rename you C star. That all stays the same, and we just need to highlight those, right click on them, quick actions and refactoring, create, yes, create. Now, stars don't have necessarily all of the things that we have here, so what assets did I prepare in advance for stars space thing? Assets. So for my stars, I had 2 things. I had star surface and star sky. Now, if I double click on these, what do these actually look like? So star sky, well, it's just a noisy Perlin noise texture with no 3D effect added to it by the looks of it. Star surface is just a big white disk. Now, You might be thinking, well, why do we need an image of a big white disk? Well, it's actually far faster to calculate and to draw an image of a big white disk than actually calculate one. So they're the assets that I'm going to use. So we need a surface, and we'll keep the other one as clouds. Now the star obviously doesn't have any lighting either. Let's go into the body of our class, and I'm going to pinch some bits from the planet here. Pinch those. And what did we call it? Did we call it surface and clouds, was it? I can't, I've already forgotten. That's what happens when you get a bit older. So this one was star surface. And this one was star sky. Oh, convenient. See, I was obviously thinking when I was naming these things. So you might think, well, what does the star sky mean? That's a good question, Jacob. Yeah, there was a bit of a joke on the Discord before about what the formula was going to be, and I just said, right, I'm going to use the square root of mass. That'll be simple enough. Is it a COVID cough? It is not a COVID cough. I have been vaccinated, and I have been tested recently too. I kind of have to be. No, unfortunately, no, it's not a COVID cough. Right, so I want to draw my star. Let's go and pinch the basic drawing routines, because it saves me having to type all these things out. And the principle is the same, right? It doesn't look very different. So we've got our GFX surface, which is going to be the base, and we're drawing these as rotated decals. The star doesn't have any lighting of its own. But the one thing that's going to be different to a star is just how enormous it is relative to the other planets. I'm also going to tint things a little bit differently too. So I'm going to tint the main body of the star. Let's just make it draw it first. So I'm going to tint that yellow. So that white disk that we created in the image is going to be drawn as a big yellow disk. And I'm going to draw the clouds on top with a slight reddish tinge. Right, so look, picking some numbers at random there. A little bit of an alpha to it as well. Let's go back into our main application, and we'll now add... Oh, we need to include it first, don't we? Add in a star. Not a celestial body, so this one is now C star, which is the sun, hopefully. And polymorphism should just take on and do the hard work for us in this instance. And whilst that's compiling, I will catch up with the chat. Ooh, got nothing. Nothing. We've got a bug. Oh, no, we've not got a bug. We've got a very, very small sun. The sun is smaller than our Earth. What is that? That's fascinating. So we've got, should have here, that the sun has a radius of 100. Let's go and just double check that we've got that right. I think we made a schoolboy error here. We've not passed these on to the base constructor, have we? No, because I didn't copy and paste the rest of the file. Aha. There we go. Bring you over. Well, wouldn't it be really cool if the sun was sort of this tiny little light bulb thing, which is really hot? Right, okay. So we've got a sun, and it's not very big relative to our planet. It could be much bigger. I think it should be much bigger. So let's change that radius. Let's make that 500, but we'll put our planet at 1,000 further out. If I just go into free roaming mode, okay. Yes. Now, a little trick, and you might not pick this up on the Discord server. Sorry, on the Discord server, on the Twitch stream. Right now, you can probably see that they're all pixelated. Well, we can do something about that in the Pixel Game Engine. Oddly enough, we can get rid of the pixels. And this is one of those things that I don't discuss very much because I like the pixel aesthetic, but you don't have to have them. And if you go to the place where you're loading the texture in the first place, so excuse me, in this case in our star here, when we load the renderable, we can in fact specify some additional things. Firstly, is it from a resource pack? No, it isn't. But is it filtered? Well, if we choose true here, that will actually do a bilinear interpolation whenever it's drawn. Ah, Manual VR, thank you very much for the subscription. Much appreciated. You just remove the pixels altogether, so you'll see the difference now. So I'll just do that for the other one, and we won't do it for the Earth model. We'll leave that as it is. So a little pro tip here, if you're not actually happy with the pixel aesthetic. So now when we zoom in, you can see it's all blended and sampled for us. And that's actually cost us nothing to do. So we can actually remove that pixely look. But if we go over to the planet, the planet itself, even though it's wobbling at the moment, the planet itself is still actually pixelated because we've not applied the filter to that texture. So that's just on here. So we can actually filter things that get rendered. Yeah, nearest neighbour is basically what's being done on the Earth sprite here, but for the sun we're using just this bilinear type filtering. It doesn't look very hot, our sun, and I think it doesn't look very hot for two reasons. One is the colours that we have chosen are just not good. I think our red is too red and our yellow is too yellow. So I'm just going to look at what colours I actually chose for the original. Oh, right, that's interesting. So I actually did keep it as a white disc to begin with for that. Sorry, I'm just looking at some of my notes for my prototype on this. I'm just curious as to. Looks like I no, I didn't specify. Oh, it's because I'm looking at a planet. No, oh dear me, looking at the wrong one. I was thinking I didn't specify the sun to be blue. What madness is this? This looks a bit better. There we go. So it looks like okay. Originally, I specified the surface to be this colour. So we'll see what this looks like. Which to me looks like a light red. That was the surface. Then I specified the sky to be this colour, which is very much red and very much green, which tells me that that's a yellowy type colour. Let's have a look. Okay, that's interesting. Well, it's certainly brighter. But I think what's going to make this look a little bit better is right now we're just sort of blending the textures by drawing them on top of each other. Instead, it would be better if we got them to sort of add to each other. And we can do this in the Pixel Game Engine too. We can actually specify how the textures are blended together by the GPU. So I can take my... oh, maybe I can't because I've not passed this through to the transformed view. So we will see. What am I doing? TV dot set. Yes, you see, I don't have this. I don't have a set decal mode. So I do need to make a small modification here to my transformed view because I want to get access to the Pixel Game Engine underneath. Now, one way to do that is not to change the transformed view at all, but also pass in a reference to the Pixel Game Engine, which may be a more sensible bet. So let's do a little quick refactoring before we get to the end here. So under the draw self, I'm also going to throw in the Pixel Game Engine. Star PGE, and we'll just, yeah, we'll leave that as it is. That's fine. And we'll throw that into our celestial body. We need to throw that into everywhere. We've got that now. one of the biggest limitations of Visual Studio is doing this. If you do actually change a base method, getting it to propagate to all of the classes that derive from it isn't as easy as it should be. Do have to do a bit of cutting and pasting in this regard. Planet. Planet. And star, the one we've just created. Star. And star. Right, okay, so now we've got the PGE. We need to, we also need to provide it when we're drawing, I suppose. Here. Provide it as this. So for our star, now we can PGE. PGE. Come on, IntelliSense, catch up with me. Set decal mode. There we go. Excellent. Now, the mode I'm going to specify is actually additive. So OLC decal mode additive. Now, once you've changed the decal mode, that's going to affect all decals that get drawn subsequently. So you do at some point want to put that back to normal. Because that way you don't want to lose control and things will start to look a bit strange. So let's see how that renders instead. Fingers crossed that all of these things still work. I need to test the PGE more when I make changes to it. There we go. So you see now the sun actually looks a lot brighter than it did before. And that's because the textures have been accumulated rather than blended as it was previously. What do I think of having all the drawing functions of PG global so we don't need to pass it around? No, don't like that idea at all. I think a lot of the functions need some of the internal information of the Pixel Game Engine, and that would require then that I somehow create all of my Pixel Game Engine's variable. It gets rid of it being an object-oriented solution. It's no, a bit of a mess. The darker colours now look washed out. Well, I think what we should do to make this look a little bit more interesting is we're going to... I want to hack something. I want to hack something as an experiment. So let's go to Celestial Body. And I'm going to hack in here just MF total time. MF total time. And as part of the update self function, which we don't really implement on the planets or the stars, update self, I'm just going to accumulate elapsed time. Like that. And that will allow me then, when I'm drawing things, I can actually specify what angle they're going to get drawn at. So I'm going to do it like this. I'm going to firstly just draw MF total time. I'm going to have to make that protected, aren't I? I've just got a feeling that... Is that accessible? Oh, it is accessible. Oh, that's okay. Good. I'm going to draw that once, like that. And then I'm also going to draw it once, like that, the other way. So, it's probably going to be spinning far too fast, but let's have a look. So now, we've got sort of a constructive interference happening across the surface of our sun. And I'm drawing it twice. They're all adding up to each other. And it gives us this sort of nice, sort of dynamic sunspot type feel to things. I think it's quite nice, right? See, doesn't that makes a massive difference? So just knowing these sort of very simple tricks, you can actually produce some very nice effects. The thing is, it's far too fast. So I'm going to slow that down considerably. Well, if I change the mixing mode, well, it is. So both of those are additive, and I think it's the fact that it's deliberately saturating now is why it gives you the impression of it's really, really bright. And here, and maybe I've slowed that down far too much. Have I slowed that down far too much? Let's go to somewhere where you might actually see some change. I think I've slowed that down so much that we can't even perceive it's moving. So let's dial that back a tad. There we go. Yes, so there we go. That's very subtle. But I think subtle is good in some sort of space effect, right? Because things don't happen very rapidly and stuff on such large objects, at least when we're perceiving them. I'm sure there's some relativistic physics for explaining why that's the case, but that looks quite nice now. It's also, the sun is very nice and bright. The only thing I don't like are these sort of concentric circles that we're seeing. Now that could be because we're using the same texture, effectively, at the same time. They're just going in opposite directions. So maybe I also want to stagger this by some value, 2 degrees. 2 radians, just to knock it off center. Maybe that'll actually stop them looking like they're too circular. Yes, there we go. So that looks better. So it's just that they're not completely in phase anymore, which is much better. Make the clouds 1% larger than the sun. So is that to sort of give it a bit of a blurry edge? Okay, no, I think that's a good idea. Let's try that. So where we're setting our scale is here. If I times that by 0.01 times 1.01. I'm going to have to actually tell that explicitly what it is. There we go. Alright, so they're now both set to be a little bit larger than the disk underneath it. Now, I don't think we're going to see much of the disk anyway, but hey, I wanted the chat to have sort of like a say in what's going on here, but I don't think it's going to be as obvious as you might like. So yeah, you see, it's a bit... Actually, do you know what? It's not bad at all. It's pretty good. Perhaps if we chose the sky, if we faded the sky textures out towards the edges, that would help too. Which is maybe something we can do in the next episode. But very quickly, all we've got now are some grayscale images, but we've tinted them and we're blurring them in an appropriate way. And I think we're getting quite a compelling effect for a star. Yeah, I think I will go away and just, if we break the edges of this a little bit, then when we draw it bigger, it'll look like some sort of flare. Excuse me. Yeah, I like that. If you flip one of the cloud textures, they can never overlap, as in this configuration. Yeah, at the moment that's very true. One of the things I would suggest is that we have several layers of different cloud textures altogether. We can also now update the cloud texture that's on the Earth that's whizzing around. Right, I've also noticed that we've hit the time limit for the show. It's been an hour. That's gone really, really quick. This one. I've enjoyed that, and we didn't get to talk about a few things that I wanted to talk about, because in the last episode we created this stuff to do header file, and I never got any feedback, so nothing happens if I don't. Do we want things like intro titles? Do we want silly noises and graphics? Anybody want to be a guest speaker? There's going to be boring bits in the future where I just need to code stuff and not sort of describe what I'm doing. The GitHub repo for this stuff, people said yes, they do want that. So I'm going to throw that in somewhere. Excuse me. Tag, show your stuff, dedicated Discord chat. So this was if people are doing space things related stuff, do we want to be able to sort of find that and talk about it in the show? But the other thing is, if you've got something that you want to show and you want it to be shown in the CodeZone show, too many shows there in one sentence, just tag it somehow, let me know that you want me to bring it up, and I'll bring it up in the stream, and we can look at it and talk about it as something else. This is not just me coding planets for weeks and weeks and weeks. Right, well, I've had a lot of subscribers. I'm very appreciative of that, and thank you for the subscription parcel. I don't fully understand what that means, but I appreciate it nonetheless. And thank you for all of the people that have followed. There's actually been a whole bunch today. Oh, another subscription there. RHK77, thank you very much for that. All subscriptions are appreciated. They provide tea and flapjacks like all the sponsorships through either YouTube memberships and Patreon, however you want to call it. Right, so yes, that is me done for the hour. We will be back next week, and some exciting news. I'm potentially thinking of doing this twice a week. We shall see. No commitment to that just yet, and definitely not Yorkshire Gold. That's just ruined the end of the stream. That Danny, sorry, Dan Destein. Nobody drinks Yorkshire Gold. Oh dear. Well, that's just took the edge off things, hasn't it? Well, on that bombshell, I'm not Jeremy Clarkson, but hey, thank you very much for watching tonight, and I will see you on the Discord server for the after party, and I'll see you next week. Take care.